I'm delighted to inform all of you that IIT Hyderabad has been doing exceedingly good work in the area of 5G and also moving into the 6G. And many of you are already aware that IIT Hyderabad has developed the first 5G NB-IoT chip, which has recently been taken for bulk production. We have signed an MOU on the May 1st with Scient, and this is going to come in mass production very soon. And you must have heard that 5G is one of the latest technologies which can help in the smart vehicles. It also has a lot of applications in smart electric meters and also asset tracking, digital healthcare, agri-tech, and a number of other areas too. So this is one of the technologies which is going to put India in as a global player, and also in future possibly a global leader too. And the same area is being taken into further towards the 6G, and a lot of research in that area also has been happening at IIT Hyderabad, and I am very delighted that we are taking part in the Atmanirbhar Bharat to take India into greater heights in the area of enabling new technologies, and particularly in future communications.
Hi, I'm going to talk about 5G technology developed by IIT Hyderabad. This technology is developed with sponsorship from Department of Telecommunications and Ministry of Electronics and Information Technology. Before we get into the description of the details of the technology developed, I would like to spare a few moments about the current 5G scenario in India. Unlike the previous generations of wireless technologies, cellular wireless technologies like 4G and 3G and 2G, 5G has drawn a significant attention globally. The main reason behind this is that 5G is not just about providing high-speed internet connectivity through smartphones, but the primary application of 5G is connectivity for a number of devices, such as IoT devices, such as machines connected to the internet. So new verticals like electricity grids, water management, and healthcare, and whole lot of other critical infrastructure will soon ride on 5G and Internet of Things. So therefore, the government has taken a keen interest in developing this technology, where we are not only a user of 5G technology, but also have ownership in defining this technology, developing this technology, deploying this technology, and also possibly exporting this technology to the rest of the world. So there is a very big thrust on intellectual property, IPR, and patents. We have been working on IP creation at IIT Hyderabad with funding from the government agencies like DOT and MIT for a number of years towards this goal. IIT Hyderabad is also fairly active in defining global standards, where we contributed significantly in the definition of 5G specifications and introducing a number of patents in these global standards. If you see this this triangle that defines the 5G use cases and requirements, this is something that is defined by the International Telecommunication Union, known as ITU. 5G offers three distinct services. One is called enhanced mobile broadband, you see on the top, that just means high speed internet. Then massive machine type communications, also known as MMTC, left corner of this triangle, and ultra reliable and low latency communications, popularly known as URLLC. And then there are other services that use a combination of machine type communication, enhanced mobile broadband, and URLLC. You can see a whole lot of other services in between as shown in this particular pyramid structure. There is a lot of emphasis on machine type communications, and in the subsequent slides I'm going to describe a particular technology called narrowband IoT, which belongs to the 5G family of standards as defined by ITU, that we have developed and that we expect to commercialize fairly soon. So what is narrowband IoT? Well, this is narrowband stands for narrow bandwidth. The system uses 200 kilohertz bandwidth, just like GSM. So it needs narrow bandwidth. And it is a cellular family of technologies. So the signals are transmitted from cell towers. And devices such as smart meters, trackers, and other devices, they'll have a modem which is called narrowband IoT modem that collects the sensor data and transmits to the cell tower, that is to the internet. So this is the general description of narrowband IoT system. It is a dedicated communication system designed exclusively for giving machine type communication, machine connectivity to the internet, but the number of devices that the system can support is very, very large. Millions of machine connected devices will communicate to the internet. This particular standard is designed for this particular purpose. And IIT Hyderabad has played a very significant role right from the definition of the standard at 3GPP up to the development of this technology, which has culminated into the development of a chip that we will talk about in a moment. The applications of NB-IoT are very wide. Meters, tracking of location, assets, healthcare, and Industry 4.0, and many more applications. This technology is fairly attractive mainly because the cost of ownership of deploying this particular modem is much lower than 4G, and the entire module that is equipped with narrowband IoT communication just comes under around less than 500 rupees, or just around $5. So it's a very large opportunity that I think India can exploit in the next few years. Just to show the kind of volumes that NB-IoT deployment can be expected, as you can see here, the broadband IoT is the top portion here, whereas massive IoT, which is a combination of narrowband IoT and another technology called category M1, category M, is the middle portion, and then we have legacy 2G and 3G. As you can see, 2G will be phased out, and the volumes of narrowband IoT or massive IoT itself is on the order of couple of billions by around 2025. Okay, so this is a fairly significant volume that should be tapped, and we developed a chipset that can address this particular segment. IIT Hyderabad has joined hands with Vysig Networks, a startup that is incubated at the ITIC Foundation of IIT Hyderabad. And the two entities jointly developed several key IPs towards the development of narrowband IoT system-on-chip. This chip uses highly advanced modem algorithms, which are key differentiators from computation, and it has a very low power chip architecture. These two are important differentiators in terms of the technology. The solution comprises of a narrowband IoT modem. It's a highly integrated modem. Both baseband and radio frequency section are integrated into a single chip. As you can see, the chip is of size less than 12 square millimeters. You can see a picture here. And the chip supports GPS for location measurement, and you can transmit the location to internet through an NB-IoT base station. It is a very low power modem. The battery should possibly last for 10 years. If you are using this chip for intermittent communication such as metering. The chip has been taped out. It has been very successfully brought up. In fact, we had 2 revisions of the chip that have been taped out, and we are moving closer to a production version that will be commercialized in the next 12 months or so. Some of the specifications of the narrowband IoT chip that we have designed are shown here. The chip, like I said, is a highly integrated one, including GPS and narrowband IoT modem. It has an application processor, to run various different applications. It has a powerful DSP processor to run the baseband modem, and a whole lot of other interfaces to enable sensor communication. What is shown here, the SoC on an evaluation board. You can see the SoC, the green colored chip here that I'm pointing out here. This is being tested with standard test equipment. You can see a 200 kilohertz RF spectrum coming out of the chip. A whole lot of testing is being done, and we will do operator level interoperability testing. We'll conduct these measurements and qualification. So the plan is to license the chip to module makers, and the module makers are the one who will supply this chip to various application providers. That's a model we are looking at. And the first large-scale application for this particular technology we think is going to be energy meters. The Indian government has announced up to 25 crore electricity meters, that's about 250 million units, will be upgraded with internet connectivity. And narrowband IoT is ideally suited for these smart electricity meters, mainly because the older technologies like 2G and 3G are going to be obsolete very soon, and 4G is a bit expensive, for this kind of application where the cost considerations are fairly stringent. We are working with the state manufacturing entities like ITI towards commercialization of this chip, especially for energy meters, and we'll also are conducting discussions with other entities to deploy this chip for various other applications. Thank you. Goodbye.